Hello, my name is Tirth Patel. This is my 2026 GHP application video for electrical and computational engineering. This video shows two projects I've completed this year that significantly shaped how I think as an engineer and problem solver. The first project is a robot that my team and I submitted for Beta Club's senior level robotics showcase. We wanted to depict a robot stealing a jewel from a bank vault. We called the robot the Jewel Jackal. The robot itself is fully autonomous and was programmed in Python using the VexV5 coding environment. After completing the initial build, the robot still required significant improvement. It was unstable and moved in a very jolty manner. I identified several structural weak points and reinforced them to improve stability. I also redesigned the claw mechanism since the original version had too much friction between the teeth, preventing it from opening smoothly and reliably. Once the robot itself was finished, we shifted our focus to designing the physical showcase. Our original idea was to create a claw machine style display, but due to budget limitations, we had to abandon that concept. Eventually, we settled on a bank heist theme, where the robot would steal a valuable jewel and escape. We built a supporting frame and constructed a cardboard structure to represent the bank. Originally, the showcase was very minimal, just the jewel, robot, and bank, since the competition requirements only specified that the robot needed to move, lift, and rotate an object. However, I decided to take the project a step further by adding interactive elements to the display. To accomplish this, I used an Arduino Uno, along with a servo motor, ultrasonic sensor, an MP3 player module, a relay board, a portable speaker, bright LED lights, and a battery source, and also various other basic electronic components. I programmed the system so that when the ultrasonic sensor was triggered, a countdown sequence would begin. This was followed by flashing lights and a servo movement to simulate an explosion. Then, pulsing red LEDs and an intruder alarm to complete the entire effect. Here is the final version of the
Don't
electronic
breach has
soldered,
been
connected,
planted.
and coded.
Charge going off in three, two, one. Warning, warning. Security breach. Intruder in the vault. Intruder in the vault.
After finishing both the robot programming and the showcase electronics, the project was ready to be transported to the convention. Unfortunately, during transportation, it began to pour rain. The cardboard structure became soaked, and some electronic components were partially damaged. Despite the setback, we managed to fix everything in the day of, and it functioned as intended.
We are once again trying.
Don't breach has been planted. Charge going off in three, two, one. Warning, warning. Security breach. Intruder in the vault. Intruder in the vault. Warning, warning. Security breach. Intruder in the vault. Intruder in the vault.
Even though our presentation didn't look as polished as some of the others, we ultimately placed second in the state, which was a rewarding outcome that I personally did not expect at all. This brings us to the Bird Phone, an interdisciplinary project I created that plays bird calls when specific buttons on a telephone are pressed. The main challenge of this project was audio playback. My first prototype used an SD card reader module which limited sound quality to 16-bit playback and did not include an onboard amplifier. As a result, the audio output was extremely quiet and lacked clarity. After multiple rounds of testing and research, I realized that I needed a dedicated MP3 player module, which is similar to the one I had previously used in my robotics competition project. Switching to this module immediately solved several issues, including sound quality, volume, and reliability. Here are a few of the bird call samples I selected for the project. This is the finished product. I also added a stop and cancel feature that activates when the phone is hung up, and I upgraded the circuitry from a breadboard prototype to a solder PCB, making the device more durable and polished.